In this video, we are going to talk about piecewise functions today. By the end of this video, you are going to be able to evaluate piecewise functions if you're given a value to input, and you are also going to learn how to graph piecewise functions. So let's get started. First, just to define a piecewise function is when you have a function that's defined by more than one subfunction, meaning that depending on which domain or input values you are working with, that will determine which equation or subfunction you input that value into. So for example, if we look at this first piecewise function f of x, you can see that there's this bracket that breaks it into two functions. This is like saying f of x is equal to x sometimes when x is greater than or equal to 0, but other times the function f of x is equal to negative x, and that happens when x is less than 0. So these two pieces here are the two pieces of our piecewise function. In order to graph these, we are going to choose a few values that meet the domain and plug them into the corresponding equation. Then we're going to do the second thing with the next subfunction domain by taking some of those input values and inputting them into our function. So let's give this one a try. Let's do this first function, this first subfunction, this first line first. So I'm going to do this one in red. So this one says, if I'm drawing a table here, that whenever I pick my x value, I have to pick an x that is greater than or equal to 0. So that means I need to pick 0 because it is included. And I'm going to draw a dot there because things will get complicated in a few minutes, and that dot is going to help us. And anything bigger than 0 is also going to be in this part of it. So I'm going to put 1, 2, and also 3. Our function for this piece says that f of x is equal to x. So I'm going to take my input value and I'm going to put it in for f of 0. So when I input the 0 in, it's just going to give me back whatever the input was as my output. So that's going to be 0. This means that my first ordered pair is going to be 0, 0. Then I'm going to put in f of 1, putting in this input value, and it just gives me back 1, which means 1, 1 is going to be my next ordered pair. F of 2 is going to give me 2, and f of 3 is going to give me 3. So 2, 2 is going to be an ordered pair that I have to work with, and 3, 3 is going to be an ordered pair. So let's go ahead and plot those, and these numbers would keep going, 4, 5, 6. So if I plot 0, 0 first, that's here, and then I have 1, 1, 2, 2, 3, 3, and as I said, this is going to continue because it's all x's greater than or equal to 0, so I could keep drawing these ordered pairs for that line. So there's my first piece of the function. I'm going to switch my color now just to make this easier to see as we do our second piece, and that's this one that I'm drawing the blue box around. So if we do the same thing again, but this time our function is going to take our input and make it negative, or multiply it by -1. Now with this one, my input values, my domain, has to be x is less than 0. So I'm going to look at 0, but I'm going to do an open dot there because I'm not going to include it. It's already been included up in the first subfunction I did in red. Then I'm going to look at things smaller. I'm going to look at -1, -2, and -3. So let's take our 0 and plug it in. F of 0 is going to be -0, which is just 0. F of -1 next is going to be -1. I've taken this x value and put in -1 for its place. A negative times a negative is positive. When I do f of -2, that's going to give me -2, or just +2. And when I do f of -3, it's going to give me -3, which is positive 3. And again, these would keep going as my x's decrease in value. So I get further away from 0 to the negative infinity side. So if I graph these ordered pairs, 0, 0, negative 1, 1, negative 2, 2, and negative 3, 3, let's see what that looks like. For this first one, because the 0 is not included in this domain, I'm going to draw an open dot at 0, 0. So I'm going to draw an open dot around that closed dot, that I already drew. Now let's keep going. Negative 1, 1 means I'm plotting it there. Negative 2, positive 2. Negative 3, positive 3. And this would keep going. You can see the trend would be negative 4, positive 4, negative 5, and then up 5, negative 6, and up 6. So that is my full function. The graph of this piecewise function is all of this red and blue together, not just one piece of it. The whole thing together is our piecewise function. So I'm going to draw over it in green. If I were to answer questions about the characteristics, so domain, range, those kinds of things, I would work with this green function here, which is the entire thing. Do you notice anything interesting about what type of function this is? Hopefully you see that it's a V shape, which means it's an absolute value function. Absolute value functions are a type of piecewise function. That's why we're studying piecewise functions in the absolute value function unit. So let's do a little bit of practice now where we're just evaluating so we can figure out what the table looks like so we can graph the ordered pairs. I have a function f of x and there are two sub-functions for it. I'm going to first input f of negative 6. So negative 6 is my input value. I need to decide which domain this input value goes in. Is negative 6 less than or equal to negative 4, or is it greater than negative 4? Because it's less than negative 4, I'm going to use this one here because it satisfies this criteria for the domain. So we're going to take that negative 6 and plug it into the equation. I'm going to do 5 times negative 6 minus 8. That is negative 30 minus 8, which means it evaluates to be negative 38. The second one says I'm looking at f of negative 4. So if my input value is negative 4, I need to again look at these two domain values and ask myself, which of these domains does this fit into? It again fits into this top one, x or negative 4 is less than or equal to negative 4, so I'm going to plug in the negative 4 to this same equation. I'm going to do 5 times negative 4 minus 8. That is negative 20 minus 8, which means when I evaluate this value, negative 4, my answer is negative 28. All right, let's look at one more of these. For this last one, f of negative 2, I need to figure out which subfunction that domain is incorporated within. Negative 2 is bigger than negative 4, which means I'm going to be using the second subfunction, not the first one in this one. So let's look at that. I'm going to take this guy and use that negative 2. So f of negative 2 fits into this one, and this one says that whatever it is, it's just equal to 7. I don't need to put the negative 2 in because there's no x in there. So negative 2 is always going to give me a y value of 7, and I'm done with that one. All right, so let's look at graphing one of these fully. Now this next one has 3 sub-functions to it because it has 3 pieces. The top one, the middle one, and the bottom one. So let's pick a color. I'm going to do red for this first one. And let's figure out what this first piece looks like graphed. If x has to be less than negative 4, that means for this function h of x, I have to pick values that are smaller than negative 4. Now I'm going to look at what negative 4 is, but I'm going to draw an open dot there because it has to include everything that's less than negative 4. So we need to include negative 5, negative 6, negative 7, but negative 4.5 and negative 4.1 and negative 4 3/4, they're all smaller than negative 4. So these values here in between negative 4 and 5 need to be included. By putting an open dot and then a straight line coming out of it, going through these other ordered pairs, it will take care of that. All right, so let's look at this. The function says that it just gives me back x for all of these. So that means h of -4 is going to be -4, h of -5 is going to be -5, and h of -6 is going to be -6. So that means for my graph, if I go 1, 2, 3, 4 to the left, and then 1, 2, 3, 4 down, that's my open circle. At -5, it's going to be down at -5, -6, it's going to be down, and you're beginning to see this line that comes out of it, so we can draw that piece. Now to do the middle piece, I am going to look at this domain. So again, looking at the function, if my x values have to be between and equal to -4 and -3, that means -4 is included, 3 is included. Those are my two ends, but I also need to pick a couple of values in the center. So I'm going to pick -1, 0, and 1, just because those are super easy to plug in. You can pick anything that's in this domain. So for -4, plugging that in, h of -4, that gives me -4 plus 1, which is -3. When I plug in h of -1, that gives me -1 plus 1, which is 0. h of 0 is 0 plus 1, which is 1. h of 1 is 1 plus 1, which is 2. And h of 3 is 3 plus 1, which is 4. So graphing these now at -4, I'm going to go down 1, 2, 3. So that's a solid dot. That is a point discontinuity if you want to review some from our Unit 2. At -1, it's at 0. At 0, it's up at 1. At 1, it's up at 2. And at 3, it's up at 4. So between -4 and +3, there is that set of points in our function. Now let's do the last one. I'm going to switch one more time to do this piece here, the last piece. I'm going to pick x's in the domain and plug them into that subfunction for h of x. Now this domain says that x has to be greater than 3. So I'm going to look at 3, but not include it. And then I'm going to look at stuff bigger. So 4, 5, 6. The equation for this says no matter what x I put in, my answer or my y value is going to be -1. So if I plug in h of 3, it's going to give me -1. If I plug in h of 4, it's going to give me -1. h of 5 is going to be -1. h of 6 is also going to be -1. There's nowhere to put this x. It always just gives me -1 as my solution. So now let's plot these. -3 or +3, -1 is going to be an open circle because that's a point discontinuity again. It's jumping. 4 is going to be down at -1, 5 is down at -1, 6 is down at -1, and it's all after that. Anything that's an x greater than 3 is going to be there. So that is what my last piece looks like. This then is the full graph for graphing this piecewise function, h of x. You can see that there are 3 pieces, the red one, the blue one, and the purple one, that are all components that make up this one picture or one graph for this piecewise function. So with all of that, you now can evaluate piecewise functions by plugging in the domain values, and then you can graph those piecewise functions by doing a table of evaluating points or domain values and then getting the y values so you can graph. Go ahead and try the Now You Try problem now.